Hello, what's going on, everybody? So today I'm going to work through this a problem with you together, which you might encounter in your statistic class. So, and obviously I don't have any preparation for this video, so I'm just gonna show you the problem, and I'm gonna just walk you through the whole process, the entire thinking process with you together. So let's go ahead and see what the problem is. So the problem said like, here are three possible models for the house. So basically the question is ask you to compare three different models, which we regard the housing price as a y variable, and the central area or the living area be another variable, x variable. So what we want is we want to fit these three models into a linear model, and we want to compare the advantages of each model and see see it in a specific condition or environment or context. So okay, so what we're gonna do is, so first of all, I'm going to use the data set. Because I already installed the data set in advance. So if you're not, you can just type in um, install, sorry, install packages, and the data set name is like, and if you haven't installed this data set, you probably want to run this command, and after that you can install it, because I already done this before, so um, it shouldn't cause any problem for me to like re-download it. Okay, so now I'm done with the um, data package installation, and next I'm going to just call this data set. What's the name of this data set? Okay, Houses. Saratoga Houses. Okay, so around it, it said there's no package called the Saratoga. Oh, okay, so sorry, my bad. I should load the library, the data package first. So the package name is like, so this will give me, okay. So next, what I'm gonna do is I'm gonna load the data set, which is this. See. Okay, so it seems like we it should give us the, okay, yeah. So here, if you double click here, you should be able to see like all the data frame. Yep. So this is um, the data set provided by the package. So next we are going to build the three different models. So the first model is that like we only have one x variable, which is the central air. So this variable is a categorical variable, so you only have two possible um, outcome. Like you either yes, you have the central air conditioner, or no, you don't have it. So let's look at the data frame, right? And we go to the central air column, which is this. So you have yes or no. So basically, it's a Boolean variable. You either have yes or no, or 0 or 1. So, and it's easy to build a model like this. So let's call this mod 1. And I'm going to build a linear model with the price as my first, as one y variable, and the central air. And the data comes from the Saratoga house. Okay, let's run this model. Okay, so it looks like the model has been built, and we can summarize the model and see what are the coefficients and residual values. So it looks like we have the coefficients, we have the intercept, which is I think 254,904. Okay, and we have the so that's our beta 0, and this is our beta 1 is a negative 76. Oh no, negative 6 is 67,882. Okay, so I think this model looks good, and but it's not sufficient enough for us to answer this question because we want to compare all the three different models. So let's build our next model. What's the next? Okay, so the next model we have is we still want to predict the price, but we will take the central air conditioner and the living area as our to x parameter. So I would say this model will be central air plus what the next is living area. Okay. So because I'm using R Markdown, so every time when I want to write my code, I need to write in this uh, this region. So as always, we just build a new model, the LM linear model, right? Price with central air, okay, and plus the living air. Data comes from the Saratoga houses. Okay, so it looks like we only expect symbol, so let's double check what is my I didn't see. Okay, living area. This living area. The same. Oh, I see. I need a equality symbol. Okay. So now we have the model 2 and we summarize mod 2. Let's see what's okay. So in this model, obviously you can see like the intersection is way smaller than the prior one, and also but we have beta 0, beta 0, beta 1 is still negative, and beta 2. So what that said is, so basically it means if you have no for the central air conditioner, so if you don't have central air conditioner, so you have 0 here, but if you have 1, I mean, if you do have a central air conditioner, that means it's a yes, right? So if your answer is yes, it have a negative impact to the housing price. So it sounds very absurd, and right. So typically we do value when people want to rent a house, they do value the central air conditioner, right? If you have this central air system, the housing price probably will be higher than if you don't have. So maybe we should compare the next model, and after that we can do a holistic analysis. So the next model, what's the next model? So the next model, we will cross multiply the central air and the living area. So what that means is I'm gonna like separate the yes or no, the categorical variable, and do a round analysis against each one of them, right? So let me just show you what I'm talking about. Okay, so model 3, we have a linear model price and the central air times the living living area, and the data comes from Sarah house. Okay, let's see. And let me summarize the model. Let me summarize model 3. Okay, so now you see you have um, beta 0, beta 1, beta 2, beta 3. You have three parameters, three x values, and so this one is the same as the prior one, but the coefficients is different. Um, this first two it looks okay. So, but this model makes more sense to me, because if you look at this, like you have a definitely you have a positive parameter, a positive coefficient in front of the air air conditioning parameter. So which means um, if you do have an air conditioner, the housing price will goes up, and but you do have a negative coefficients for the correlation of the central air and living area. And it kind of makes sense. Like imagine if you if you do have air conditioning and you have a very large area, right, living area, which means maybe you need to pay more for your utility bill. So maybe people don't value that too much. Like imagine you living in New York, you already have very high rent, but you also need to pay your um, like electricity, your gas. But if you have a large living area, the central air conditioner might not be that much valuable, because you so for a central air conditioner, essentially they will provide the heat for the entire house or your apartment or your studio. If you have a larger living area, which means it will cost you more than a heater. So maybe if you have a very big house, and you might just want to buy a heater and put it in front of your desk, and that will help, um, and it will save you a lot of money from like paying your utility or electricity bill. Okay, so now we have all the model has been evaluated. Also, you can just use the built embedded function like the mean function um, for to just see what's the mean value um, for each model, and I believe you can do it this way. Yeah, so if you have yes, so this will be the mean. If you have no, you don't have central air conditioner, that will be the mean. Okay, so you can definitely do this for all three of them. Also, you can use a variance, right? Central here. Let's see. So, yeah, so that's a variance for this model. Um, so next I'm gonna do is because right now we have all the model built up, and but it's just hard to say. You know, we can barely imagine what's going on for this model. What's the meaning of that? I mean, obviously we do like if the beta the coefficient is positive, that means it does have a positive impact in the predictor. But if you're negative, that means your y value will decrease and your x value goes up. So, but I don't feel that's too convincible, especially imagine like human being or like visual animals. So we want to visualize this thing. So next, I'm gonna say I will visualization. Okay. I'm going to just draw a very simple, maybe a box plot or any other. Like let's try like box plot and see if it works. this could be the most common one because remember we have we if we only want to analyze this against the central air, a categorical variable, so that could be sufficient, I assume. Okay, so okay, so now you can probably see like if you do have the central air conditioner, this is gonna be your like percentile or whatever you want to call it, like the plot, the box plot. You can see that probably like what is the 25%, what is the 75%, what is the median, what's, you know, you can just tell from this graph. But anyway, like I'm plotting this is just to help you understand like what's going on in the real data set. So if you really want to see like the correlation or the relationship between these two um, attributes, then you can probably like doing this. Um, and I'm thinking maybe we can do more. Like if we want to, we really want to compare this to model. I assume we probably can try this. So what I'm gonna do, let me think. How about let's plot the residual values. Oh wait, let's plot the fitted value. Let's see what's the fitted. Okay, so that doesn't look good. I mean, that's not very helpful. Pretty sure the residual value. Okay, maybe let's plot the residual. You can see this is a residual, so which means after you fit the model and you use each x parameter to predict the y, what will be the difference between your predicted value and the actual value. And you can definitely you can see like this distribution, most of the data point will be concentrated around 0, which means if you have like a model that all the data, all the residual value is exactly 0, which means you don't have a residual error. That means your model is perfect. But it's, in statistic, we also consider that because we want our model to be predictive, so maybe you should consider maybe your data set is just overfitting your model. But in this case, we can almost see, that let me think, is all the data point will be concentrated around 0. So I would say this model is very promising, but you still need to analyze it and compare them across all three of them. So let's see. Look, this one is much better. And let's plot the third one. Yeah. So it's really hard to tell like which model is the best, but under certain context, you can definitely say like which one is being preferred, which one is more preferable. So let's look at the question. So suppose you want to find out how much the price will change if you install a central air unit in the house without changing anything else. So this one is just, so the first sentence is just give you a assumption that you won't change your living area. So central air conditioner is the only variable, only the changing parameter that you want to like study. So for that sake, I would say definitely the first model is the best, because like remember, because assumption is that you will not change your living area. So that means if you have X square feet for your living area, you want to change it. You will find another house that is also X square feet, but with or without an air conditioner. So that will give you give the model the ability to like analyze this situation. So in that case, so the first question, which one is most appropriate in this situation? Definitely the first model. Model one is the best, because you just want to reduce the noise. You don't want to introduce a new parameter and give you more like just introduce more noise in your model. So the first one is the best. And the second question is the second assumption is that you move from a house without central air to a house with central air, and you want to find out how much the price of the house will change, generally speaking. So which model is the most appropriate? So for this one, we do want to compare the last two model. So the second model and the third model, because so the assumption is you want to move from a house, but the question didn't say like you don't want to change your living area. Like when you move to another house, definitely you may want a larger living area or smaller. So that one, definitely we would just need to keep this assumption in mind, and we can look at our second model and the third model, right? Just look at them. What you will see is the second model only have beta 0, beta 1, beta 2, which means two parameter, and the model also indicate that if you don't have the air conditioner, so it will be a negative impact. Wait, oh yeah, this one is that the air conditioner will have a negative impact in your housing price. And the third model is that like the air conditioner will give you a positive impact in the housing price. Just 1 second, please. Let me double check like if this one is negative. What that? Okay, so it's because I forgot to say that here it said air central air no. So if you have no, it's a negative, which does make sense. Just let me double check what this positive or negative sign means. Okay, so I'm looking at an example which also gave us the okay, so I'm looking at this example. So this model, it fit a salary with a sex, so you can have male or female, so it's also a categorical variable. So what that says, if you have a male, it will have an impact. The average is estimated to be this, because if you have, so male will be 1 and female will be 0 in this case, right? Because it says the average salary for female is estimated to be the intercept value. So the male you will added this to that. Okay, so um, okay, listen. So I may said something wrong um, before, like when I interpret explain like why this is a negative, why that is a why this is a negative number, right? So this negative means if you don't, because look at this, like if you know you have non-air conditioners, you will have a negative value for that. Which means if you do have a central air conditioner system, you will not have this negative impact in your model. Um, so I know it's kind of weird. So, but this does make sense, right? If you have a central air conditioner, so maybe your landlord will price you more because of you have the air conditioner. But if you do not, if the landlord does not provide this, maybe you don't want to pay that much. Hmm. Yeah, that makes sense. But this model 3, is that do have a if you do have a central if you don't have a central air conditioner, then it will be a positive impact. And if your answer is yes, then you don't have this 53,000. Okay. And if you have no central air conditioner, but you have maybe a larger living area, and so your living area increase, this will be a huge negative impact on your housing price. Interesting. So which basically said this, as a landlord, they totally understand that if I have a very large living area, I should provide a central air conditioner to people. Okay, okay, okay. So, I mean, for all the models, it has to be built under certain assumptions, and all the numbers can be explained in any any way. Like in different business setting, this might mean different things. So I hope you maybe just think more creatively. Maybe you have more knowledge than me to understand this under certain business setting. So I can just give you a basic taste of how this gonna be, like how do you compare this three different models and how to apply it in certain condition. So if we get back to this question, so which model might be the best? Um, I probably would say the third model will be the most appropriate in this situation. The reason is that um, just provide more information. For the second model is just to say give me your living area, as a numerical value, and answer me yes or no. You have air conditioner, and then I just plug in this to number, and the model will give me a predictive value. But uh, so the second model only consider the central air conditioner and the living area are two independent variable. You know what I mean, right? So they only have a linear relationship. But this one, the third model, because we introduce a fourth parameter, this one, that will give you a little bit um, make more sense, because the answer you either have or does not have an air conditioner does have certain relationship with the living area. So this one is just giving me a little bit more give you a little bit more information about like if you have a larger living area, if your living area gets larger and larger, and you don't have an air conditioner, that will be a very negative impact on your housing price. Okay, so I think this um, help you understand better about like how to use a model, how to use different like model specifications, and to analyze each model and compare them, um, and provide an answer under certain like context. Okay, so I hope you enjoyed this video, and please give me a like if you do find this might be a little bit helpful to you, and thank you all.